Thank you. And our next speaker is Dr. Rudolf Bannasch, who is Managing Director and co-founder of EvoLogics GmbH. The title of his talk is Bioinspired Subsea Robots and Underwater Networks.
Yeah. Where shall it be fixed? Oh, ladies and gentlemen, hope you are not sleeping yet. It is always a crucial thing to be the latest, as the last in the line. I will try my best to wake you up, guys. So it brings you to my favorite environment, to my favorite animals. But I used to be a marine biologist in my first life. Then I moved to an engineer. Now I'm a manager and and a presenter. So bio-inspired robots, it's a wide range. I was working with dolphins, with manta rays, with penguins 20 years in the Antarctic and so on. And there was always a dream to take some of the discoveries we have made into the technology, into engineering. And when we started to build the first underwater robots, so it turned out most important is to keep everything under control. You will not risk your work, your reputation, your money. You have the most important thing is to have a stable communication, navigation, positioning. And at that time, when we started, that was in 2000, with a company coming from the Technical University, Berlin. We had a startup and decided to go into this bionic robotics. But at that time, nothing was really working underwater. That trick of the dolphins we have found out, we could work with dolphins in trained dolphins in a basin and ocean area. What we found out is they are singing underwater. They are not using constant frequencies. That is to overcome the problem of multipass interferences, because in the case of multipass, all reflections come with the same frequency. They come with distortion, time delay different, but the same frequency, and they can fantastically interfere. If we have a wide range of different modems now. These are commercially available. Most of you, or many of you, know that. But they give us a possibility to interconnect robots underwater, stationary system to surface system, and we have also a communication system to the satellite, and we can communicate to chips and also divers. So the complete network configuration. But these modems are becoming more and more clever. We have powerful processors on board, so they can do a lot of more jobs. We can use the same signal, and that is a big advantage of these singing modems derived from the dolphins. We call it S2C, sweep spread carrier technology, that we can use the same signals with modulations on it for communication, a reliable communication, and also for positioning. We can measure the distance, the time traveling with the highest accuracy, and we can do USBL, LBL positioning with that. We can connect sensors to the data logger. We have a memory on board, mechanical control, and you can set up networks. And that is something what you would really need here. And with this capability, we said, okay, when we have these LBL beacons for position and or USBL positioning, LBL mostly, then we can add some sensors. We can integrate. It can do a very useful job. And this was here integration of CDDs and all these oceanographic sensors, multi-parameter probes, and so we can use them as a multifunctional device. And that is very useful. That was in a project we called it Seamount, that was to detect sources of fresh water in the ocean. where the water comes out, the springs underground. So these were the beacons for that, and I will show you the deployment scheme. We put a lot of effort in order to make it intelligent. You can browse through these stations to the bottom. Then you send, hey, what is it? Go ahead. Then you can send a trigger signal. They automatically interconnect. They measure the distances between the stations and also the acoustic properties of the channels. And they send you back a report that can be used, that's shown directly on the map. And then you have the possibility to use GPS and or GNS and do it from different sites. And then you can have accurately geo-referenced operation area. That can be a large area with many stations. And in that area, you can operate with AUVs, ROVs, whatever you like, divers, and you can have a very accurate positioning to the DC centimeter accuracy. And theoretically 1 centimeter, but in practice, you know, that is not always so. But it's not only inside the area, but also in the acoustic reach of that area. Yeah, so there is a special software for that developed together with Antonio Pascal and other guys from Portugal, from Spain, from Italy. I must say there's a very powerful cooperation in Europe. Many projects also with Norway and others, to set up to make these systems more and more intelligent. We can set up huge underwater networks, and with integrated sensor can be different kinds of sensors. And also for coral reefs, we had a question from the seismic guys. Can we put seismic nodes in a coral reef? So, hey, guys, what do we want to shoot there? But yeah, but anyway, we were thinking how to organize it. There are so many points there. And we said, okay, we can cluster. Yeah, and if we put clusters together and a buoy on top, then we can manage this problem with a data transfer. And that might be also interesting for coral reef monitoring. Yeah, we can have different configurations for of these networks. So the simple thing is just data hopping to have a longer range. Then we can have star configuration. We can have adaptive paths or collective waves and a mixed configuration. And what I wanted to show you today is most interesting also the swarm operation. Yeah, because here we were working together. Antonio Pascal did not show this part of the video, and the WIMAS project that was about these streamers. To replace the streamers by a group of cheap AUVs carrying short antennas of these with these hydrophones, and the beauty with that is that the antenna is adaptive and you can navigate it close to the ground. Of course, you can do a lot of other things with it. Military people had an eye on it. Oh, it's interesting. But I think for monitoring purposes, it's a fantastic technology. Yeah, and another very interesting project was this Shell X Prize. A few years ago, Shell announced a task 250 square kilometers should be mapped at 4,000 meters within 24 hours autonomously. Yeah, and so there were many teams from all over the world. We were cooperating with a German team from Fraunhofer and also with the Japanese guys. So there was someone from Tokyo. Yeah, and that was very interesting. And there was a new development, which gives us really a new kick now. So the Germans, they had 5 of these great divers And surface vehicle, unmanned surface vehicles, which were inflatable catamarans. Their task was to carry the AUV to the area of operation, no people allowed in that area. Yeah, and then from then to start and support the ship. The question is how to organize this underwater positioning at that depth. Yeah, and the normal USBL method is you send a signal, you get a response back, you measure the time traveling and also the direction, and then you bring the position down. So it's 3 times the whole path. We said no with Antonio Pascal again. I must say, very good cooperation. We can do that. He mentioned that before. That is why I come back to that. We can use atomic clock. We can synchronize the whole network, and then we have the chance just to broadcast signals from the surface, and all vehicles in the depth, they will listen to it. And they can they get the GPS time and the position of the ship on the surface. So all these can give the positioning, and maximum repetition rate we have estimated 8 times per second. A very high accuracy for that. But of course, in practice, maybe 1 or 2 times a second, you get a repetition of that. So a very powerful development. The other thing is our own development of smart robots. So I want to show you my favorite, of course. That is, hey, why doesn't that start? See the same problem with that? They should work automatically. Hey. But it seems to be the computer. I told Antonio that it can't be, yeah. Hey, hey, wake up. Do we have a special trick for that? Yeah, I'm trying. It's me, so that's a problem. Oh, I wanted to show you this marvelous. No, I have integrated into the. I will try the next one. Maybe that works. Okay. Yeah, that is working. Unfortunately, that was much more beautiful in the basin when we had it still on the cable. The first, it was more gentle in the basin. So this is to show that the manta ray with this flexible wings can go very close to the ground, can do a very nice operation, can have the wings stable, just as a control surface and with sensor surface. But it can operate also close to the ground. And it has additionally jet engines here. Oh, sorry, what is that? I was too fast. No. Back, guys. Yeah, no. Hey. Okay, we go ahead with it. Anyway, it's still late. So this is a swarm of them. They are operating together, and they have jet engines addition. So hydrojets. So you can go very fast. The idea behind was that these gliders are very slow and they cannot operate in shallow water. We were asked by people from the Baltic Sea, can we do something? And I said, yeah, we must have something more flexible and with the ears. And if a ship is coming, or we are in the Strait of Malacca, we have heard, then they can fly away and they can do crude maneuvers and they can operate in a very small confined areas. We have an artificial reef in front of Warnemünde in the Baltic Sea, and we did the training there in a confined water, and a very good performance. But this is still research. I'm bringing you my research, and so we see that this manta rays, they can operate in a swarm. And here we have a surface vehicle, our sonobot. That is the earlier version in a follow mode. It goes behind and you have everything under control. It stays just above or closely behind. So we have a very good, very accurate acoustic communication. Yeah, and also get rid of the multipulse configuration there, and works very stable. And can we go ahead? Yeah. Okay, and they can cooperate also with diver. So we have a heterogeneous swarm with a man involved, with a manta rays, and yeah, working together. I wanted to show you this, and this is another of my favorite animals. This is derived from the penguin. Penguins turn out 40 million years of evolution under the most extreme conditions of the earth have shaped these animals to the extreme. Yeah, and their drag coefficient, their body drag, is 20 to 30% lower than in any robot, any torpedo rocket ever built by engineers. Don't believe that you have friends when you are bringing those results. Where did you measure this? Where are you coming from? And so, but is fact only after we have when we had repeated the measurements in the US, then they started to believe. But this is nature, and we can build those things. And this is our Poggy, the small whale, derived actually from the manta rays. That is the trunk section of the manta rays. Some people were in doubt over the wings. Why do we need the wings? I said, okay, we can replace the side sections by conventional thrusters, but in this case we have a double tail. Look at this nice performance. It can change the angle and can fly at any angle. You can adjust horizontally and turn around. Highly flexible. You see they have the DVL here. We have a lot of sensors integrated. Yeah, and so they are well prepared for most of the oceanographic measurements. We have side scan sonars, high resolution stereo cameras on board. Yeah, and we have these oceanographic sensors, and so it's full of sensors. And the idea is to have the most compact form. To all robots should fit into a back compartment of a conventional car. No extra logistics, no cranes and those things, one or two people for a deployment. But the problem is with all these sensors, they get higher resolution, 4K, and now people are dreaming about 8K and what to do with the data. The problem is the acoustic link has a very limited bandwidth. Yeah, and so we have to do something. Look at these sensors. I have a list of these sensors that is for navigation, for the internal sensors. Yeah, with the CTD, ADCP, and here the multi-parameter probes. You see, there is a similarity with the stationary equipment. We are trying to use a modular construction. As a robotic toolbox we are using and collecting together, so all systems are compatible and interoperable. You can change the parts and put them together, and we try to use the same sensors at all these different devices. So, and what we need is, with this large data, we can store them. We can build intelligent data banks and storaging. But what we need is an intelligent onboard processing. And we put a lot of effort in, and this is our artificial intelligence module. That is actually a Jetson board for those who are interested in the details, and combined with interface boards. And so we can stick up to 5 cameras to it, high resolution cameras, and we can stick all the sonar to it and other sensors via Ethernet. So this gives us a lot of possibility for multi-sensoric analysis. Yeah, and oh, that was high interest. Our people from the army are interested in those things, but I wanted to show you the handling. Because the approach was, okay, about the music. The approach was next year that one person can handle it. Actually, my sons can put it in the water very easily. And I wanted to show this that it shows also the program. And a lot of effort in the graphic user interface. Can download the map and program map. It proposes you the quick for the measure. It's easily adjust and you links to the mouse, and your system is ready for the test. And then the robot will follow the high resolution. What is a GPS with RTK? Yeah, and this is another same the same robot now with the artificial intelligence module. Actually, we have seen there is a microwave still in front of us. I show you some very basic.
These days, maritime robotics serve more and more applications.
I must say,
For many of them, smart functions and intelligent robotic behavior are key to success. To make these robots smarter, the engineers at EvoLogics have developed high-end object recognition technology. It works in real time and automatically reacts to objects in sonar and video data. It is now available for all of EvoLogics AUVs, ROVs, and USVs.
There was another ask from the Netherlands police, water police, wanted us to assist in searching for people underwater. Sometimes very that was but I think we will train our robot accordingly, and what we used to dive ourselves and also to put the dog in the water. Very interesting. I as a brain guy, sometimes I do not really recognize the possibility is also to train other objects, what we are working now and what we are doing. This is also a separate training of a camera. You have seen those things from other colleagues as well, what the excellent work from Woodsole. We have done here a little exercise in the garden pool of my son. Yeah, some fish. But this is, you see, the possibility. And all of these fish can be georeferenced. All objects you are finding underwater, that is, they come, and the question is now how to handle this big data. It is not that we have to transmit raw data or compress data. Even data compression does not help very much. What we have is a semantic information compression. But the neuronal network really extracts the information you need. The question you are asking, and it tells you the person is there with a Z position, absolute coordinates, and gives you the absolute time to together with it. That is the amount of data you can easily transmit, yeah, and you can easily show on your screen. And the original data, they are on the device, and you can come back to that later. So this gives us also a possibility to go into the deep sea, deep ocean. Yeah, some creatures, nobody of us has seen them. Yeah, you see them from books or so. But we have contact with the guys who were working there from the Geomar Institute in Germany, and also BGR, the Bundesamt für Geowissenschaften and Ressourcen in Hanover. And they provide us video and photo material, so we can train our networks. We can also look for the minerals underwater and train the devices, or let's say the artificial intelligence module. The beauty with that is we can train this module on any platform, and then we can transfer the programs, and all other robots will be trained in the same way. And if you are using the same sensor set, that is another interesting aspect of standardization. And to bring these sensors together, to use a standard, to use something, with what comes out of one box. So we have a project here in Germany running that is called deep sea protection. That is for manganese nodule mining. And the idea is here that we have a combination of a stationary network. You need anyway beacons around it for positioning. In the deep sea, it goes to 6,000 meter depths. Yeah, and we want to integrate a task force of AUVs. Yeah, in this case, maybe mantas or poggies, doesn't matter. And they should be resident on the crawler. The crawler is interesting. You have a cable, the umbilical. Yeah, you have a glass fiber cable to the surface, and you have a power supply. And so we can use that, can utilize that. We can have the beacons with vertical probes, yeah, and for profiling, or we can make the AUVs resident. Yeah, and it can be the crawler itself, or can be just a power bank. Yeah, and so we will be fully independent. And we do not need to blow them up with big batteries, and then you have the big batteries, you need the syntactic foam, and the whole thing becomes bigger and bigger. No, we can reduce it. Say, okay, we put the limitation, 10 hours work is okay, and then come back, recharge, exchange data, get the new program, new option. Or another option is here to use let's say this for wind power, wind park inspection, a new development now with the shipbuilders together. They said, okay, we can have a huge moon pool. We put a basket in, and please make your AUVs to fly in. And the other thing is there's a very good synergy and very close to the questions of critical infrastructure protection. So in harbors and what is other crucial areas, we can use resident AUVs. We can use the surface vehicles here, like these sonobots. We can have complete networks. Recently, what is the state of the art? They have single sensors for divers detection, for example. Yeah, and but we can use complete networks, and nobody will sit there the whole day around and 24 hours, 7 days, and watch a TV or listen to a sonar, a diver detecting sonar. So that should be done by a neuronal network. And the other thing is maybe we need to add some sensors. These penguins, they will be available, I hope, next month. They come out of the shell and out to the market. And but for the security aspects, would be nice to have another sensor. We said, okay, we can add 3D fluxgate magnetometer. I'm just finishing. Yeah, okay, and we can operate them in swarms. So we can use this USB AUVs we have here, different constructions, and or we can replace them by a sonobot. And so the whole thing will be operable and can be managed from outside. And the other very interesting aspect also for ecological monitoring, in this security scenario, even if you have not trained the object, if you repeat your observation, your monitoring, and superimpose the images from the last time, then we can make the change detection. any anomaly, any changes from the last time that can be shown directly. Yeah, and that is very, very important also if you are looking for changes in the coral ecology and so on. So a very, very good similarity. And what we have also achieved is good progress in the diver communication and diver orientation. We have a little handheld device that can be used with a USVs positioning from outside. So the diver will always know where he is. Another development is with this, what is it, wearable head-up display. Yeah, but I think this is also already in a commercial state. So actually, there are a lot of challenges in front of us. And what we have heard today, interesting talks and interesting aspects, streams for the future. There are not only challenges, there are also synergies. Please look what is in the security part, ecology, or deep sea, shallow water. Yeah, and if we can build our robots in a pressure neutral system, no pressure house, no vessels, that the electronic itself is sealed. So then micro nano coating will replace these huge vessels, titanium and steel vessels. So the technology comes from the space research and from other areas. We want to integrate, and we want to invite you to cooperate, because there are so many things in front of us. We can, in the best way, we can develop them together. And that is actually what I wanted to show you, and why I'm here. I hope that we can assist you, because our commitment is we want to provide you the best technology. And being still a scientist, I must say, we know how much we suffered from the lack of technology. And if you have a scientific program and you start with a cheap robot because the budget is so small and we try to adapt, and so let's start at a high level. And if we bring that together, then the price goes down. And that should be our chance to have toolbox, to have a system from the shallow to the deep water, to bring it together. And that is what I have heard today, that there might be an interest in that. So thank you very much. If somebody has interest, we want to go. I know we want to leave, but there is a little thing while we are leaving. I wanted to show you if it works. Just look forward if you want to go.
In cooperation with its partners, ThyssenKrupp Marine Systems is developing a modular system for an innovative vehicle class to explore and harness the world's oceans.
If you want to go for the big,
MUM is unmanned and autonomous. Due to its unique benefits, the new vehicle is ideal for industrial use in offshore energy and maritime security, as well as in maritime science.
In the second stage already of the development.
MUM has high availability, as it performs on the bottom of the sea without influences of waves and weather.
That laboratories, that universities can have full labs.
MUM can be tailored to specific needs. Its modular design enables the new vehicle to be customized for each mission. Variant quantities like fuel can be freely combined with custom mission modules. The final system enables even unusual and highly specialized tasks to be performed efficiently.
And of course we will have our batteries in as a symbiotic.
Possible activities range from payload transportation and operations to research missions and stationary deep-sea tasks. MUM cares for nature. Its emission-free fuel cell energy system makes the underwater vessel ideal for use in highly ecologically sensitive environments. MUM is efficient. Individual modules can be reused, permitting a significant reduction in costs and much quicker development cycles. Transported as standard containers, individual modules can be assembled to customized vehicles. MUM, one system, multiple configurations,
Thank you very much.
new possibilities.
And finally, I want to thank all the audience, all the speakers, and Professor Eric and other organizers for organizing such an exciting conference. And this concludes day one of the conference. Thank you very much, and good evening, gentlemen, ladies and gentlemen.